All right, these notes are pages 19 and 20, and the title is Factoring Quadratics. So let's turn to page 19 and 20. It doesn't matter which page you start on. Remember to put your title, Factoring Quadratics. And the first set of notes we're going to do is over monic quadratics. And that just means that there is a 1 in front of the x squared. So we don't have any other number in front of the x squared except for 1. So an example of a monic quadratic is x squared plus 5x minus 14. Right? And if we want to factor this the way we've been talking about, a tool to help us organize is if we use our factor puzzle. And remember that the negative 14 goes on top of our factor puzzle. And I'm just going to use a highlighter to help show where those numbers are coming from. So the negative 14 went on the top of our factor puzzle, and the positive 5 goes on the bottom of our factor puzzle. All right, so that's where those numbers came from. And remember that we need two numbers that multiply to give us negative 14, but add to give us the positive 5. So start listing your factors of 14, 1 and 14. That will not get us to a positive 5. 2 and 7. If we use a negative 2 and a positive 7, that will multiply to give us negative 14 and add to give us positive 5. And then don't forget that then we need to write our factors. So we're going to use the negative 2 and the 7 as our factors. So our first one is x minus 2, and that negative 2 came from the first factor that we found. And our second factor is x plus 7, and that factor came from the positive 7 that we found. So we've completely factored this. There's no more factoring that we can do. So another example could be n squared minus 2n minus 48. Okay. So let's go ahead and set up our factor puzzle to help us. We want two numbers that multiply to negative 48 and add to give us this negative 2. So sometimes right away you don't see the factors, and so you have to find a way to organize your factors. So 1 and 48 we're going to start with. That is not going to get us to a negative 2. And then we're going to just start dividing by possible factors. So we could do 48 divided by 2, which gives us a 24. So that tells us our factors are 2 and 24. That won't help to get us to negative 2, so we're going to try again. And next we're going to try 48 divided by 3. And that's going to give us 16. So we have factors of 3 and 16. And no, those won't work to get us to negative 2. So try again. 48 divided by 4 is 12. So our factors are 4 and 12. And no, those don't get us to a negative 2. So we could try 48. 5 does not go into 48, so I'm not even going to try 5, and I'm going to try 6. And 48 divided by 6 gives me 8. So we also have factors of 6 and 8. And yes, if I use 6 and 8, I can get to a negative 2 if I make the 8 negative. So that tells us that 6 and negative 8 are the factors we should use. And since our variable here was n, instead of putting an x in my factors, I'm going to put an n. My first factor should be n plus 6, and my next factor should be n minus 8. Okay. All right, So let's go on to the other page and talk about what happens when our quadratic is not monic. So non-monic, draw yourself a thought bubble here. This is your coefficient of x squared is a number other than 1. So in our polynomial, we're going to have ax squared, where a is not equal to 1. So it's going to be any other number except for 1. All right, so when we are going to factor a non-monic polynomial, let's first start with the example of 3x squared minus 17x plus 10. And I'm going to walk through the full long example first that we did in class, and then we'll go through the shortened version. But I want to make sure that you understand where all of this process comes from. So in order to get a square number as our first term, we're going to go ahead and multiply through by 3. So we're going to multiply every term by 3. So multiply 3 times 3x squared, and that's going to give us 9x squared. And we're going to multiply the 3 times the negative 17. And because eventually we know we're going to want to have that 3 separated out, I'm not even going to waste my time multiplying those. I'm just going to write it as 17 times 3 with our x. And then the last thing we have to multiply is the 3 times that positive 10, and that's going to give us a positive 30. So remember in class that we can actually rewrite this 9x squared. Since 9 is 3 squared, we can write this as 3x quantity squared minus 17 times 3x plus 30. And in class, remember that we decided we could rewrite and assign a variable to that 3x to make this simpler for us. So let's call m 3x. So that means that anywhere in my original polynomial, anywhere that I have a 3x, I can now instead replace that with m. So this polynomial becomes m squared minus 17 times m plus 30. And now this is a monic polynomial, so we can go ahead and factor it the same way we just did those others. So for example, we're going to have a 30 on the top and a negative 17 on the bottom. And we still have to be able to find our factors here. So 1 and 30, those don't work to get us the negative 17. So let's try 2 and 15. Yes, if I make both of those negative, I can add them to get a negative 17. So let's fill those back into our factors. We have m minus 2 times m minus 15. But remember that we switched out that m, and that m really is 3x. So we need to come back and put that 3x back into our problem. So we have 3x minus 2 times 3x minus 15. We want to see if we can factor anything out of either of these terms. 3 and 2 do not have any common factors, so there's nothing there that we can do. We're going to just bring that factor down. But there is a common factor between the 3 and the 15, so we can factor that out. When we take out the 3 from this, we just have an x left. And when we factor out 3 from the 15, we have a negative 5 left. Since way at the beginning we multiplied through by 3, now we have to undo that. We can't actually leave that 3 in our problem. So we need to go back through and divide by 3. But that's nice because we found that 3 that we multiplied there, and those two cancel out, leaving us with factors of, I'm going to write them over here, 3x minus 2 times x minus 5. Okay, so let's talk about what we can do to simplify that process. So we do not need to go through, since you know that you're going to do all this substituting piece, we can skip writing those steps and make this process a little bit simpler for ourselves. So if we have, for example, let's see, what are we going to do? 5x squared plus 17x minus 40. Since we knew to get this 30 in our factor puzzle, we started by multiplying, let's come up so we can see it. We multiplied 3 times a positive 10, that gave us that 30. So in this problem, we can just go ahead and multiply our 5 times our negative 40. And go ahead and fill that into our factor puzzle. So 5 times negative 40 gives us negative 200. And the negative 17 in our factor puzzle came from our original problem. We did not change this negative 17. So in this new problem, it's just going to be the 17. We're going to fill that in. All right. And then we can go ahead and start finding our factors. So our factors are 1 and 200. That's not going to get us to 17. Okay. I'm going to use this space over here to help find our factors. So then we're going to try 200 divided by 2 equals 100. So we have factors of 2 and 100. Those don't get us to 17. So let's divide. 3 is not a factor of 200, so I'm not going to even try that one. But 4 is, so let's divide 200 by 4 and get 50. So we have factors of 4 and 50. And those won't get us to 17, so we're going to keep trying. 5 is a factor of 200, so we're going to divide that and get 40. So we have factors of 5 and 40, and those don't get us to 17. So then we're going to try 6 is not a factor of 200. 7 is not a factor of 200, but 8 is a factor of 200. So we're going to divide 200 divided by 8 and get 25. So we have factors of 8 and 25. And if we use a negative 8, we can get negative 8 plus 25 will give us 17. So we found our two factors. And we can come back and fill in our parentheses. We knew that in our original problem, the thing we substituted was our very first term in our polynomial. So here our first term is actually 5x squared. So we know the first term is going to be 5x in both of our factors. So we have 5x minus 8 and 5x plus 25. There's no common factors between 5 and negative 8, so that term is going to stay the same. There is a common factor of 5 between 5 and 25, which is the 5 that we originally multiplied by, so we know that that one is going to cancel out. So when I rewrite this, I know that I am dividing both of these terms by 5. So 5 divided by 5 just leaves us with 1x, and 25 divided by 5 leaves us with a positive 5. So our final answer is 5x minus 8 times x plus 5. And we have completely factored and we're done.